Hello everyone, I am Dr. M.S. Surendar from BVRIT, Department of BS and H Mathematics. Today in this video lecture, we are going to discuss about some peculiar topic in advanced calculus. The topic name is Introduction to Laplace Transform. Okay. First of all, we need to know about why we need to study Laplace transform in the sense. So simply I can tell that it is very powerful tool to solve various types of equation. What kind of equation we have to solve using the help of Laplace transform? So various types are there. Especially I just give some equations, you are very familiar that kind of things. Especially first one is linear ordinary differential equation, and second one is linear partial differential equation, integral equations, and integral differential equations. Equation involving both integral and also differential. Both equation involving only equation is integral differential equation, and also difference equations. These are some particular types we can solve. What does mean this difference equations? A difference equation is nothing but it is called recurrence relation. Okay. Another name is that it is called as recurrence relations. Another word. This kind of equation we can solve with the help of Laplace transform. Not only this, okay, these are some peculiar topics in mathematics. Actually, these 5 types, not only in mathematics we are going to solve in many fields, actually in physics, chemistry, in economics, as well as our engineering topics. The 5 equations are play a major role. Okay, so with the help of Laplace, we can Laplace transformation, we can solve it. Okay, so next thing is here Laplace and transform. First we need to know about what is the meaning of transform first. Okay, so just I had write that what is mean transform. So transform in the sense two things will be there, some input will be there, another something, some output will be there. Okay, in between, suppose I have a computer like that, that computer doing the operation of transform. So some input is there, this is called some transform. Okay, my computer doing the job, something like that, you have to think about it. Something I have to put an input and I get output, it will transform to something else, output will be something. So here this transform, this is called as transform. Okay, so in Laplace transform we have to think about, suppose input is some function, it is function of t, it is my function, and output will be, how I mentioned this, it is called output is some capital function of s. Okay, so it is the input is this function of t and my output is capital function of s. So I just mentioned that it is transform with s, actually subscript like that I mentioned just for understanding purpose. So okay sir, then how we write this in mathematically how to write this in the sense, it is t transform is act on the function small f of t. So what is the meaning of this? The transform, it is acting on the function f of t, I get output capital F of s. Okay, so it is mathematically we have to see like this. So this representation, what does it mean? Means After applying the transformation, my output will be f of s. This is my input and this is my output. Okay, full. This is my input and this is my output. So next is our Laplace. Okay, transform is okay. Laplace transform you want to study means what are the things you need actually? What are the prerequisites? So before we need to study Laplace transform, what do you need? Actually, what do you need to understand and what are necessary things we need? In the sense, two things we need. First one is just integral calculus and differential calculus. Integral calculus and differential calculus. These are our prerequisites. These two things are necessary to study about Laplace. Okay. So before going to study again Laplace transformation, I am going to introduce what is that means integral transform. Integral transform. Suppose given function is f of t. Okay. So for this given function f of t, I am going to do some transformation t is equal to. So how do I define this integral transform? The definition is I put the limit, integral limit t is from t0 to some t1. Okay, t0 to t1. K is function of s and t into f of t dt. Okay. So any function f of t is given, I do one integral operation. Its limit from t is from t0 to t1 and multiply something k is function of s and t into this given function f of t into dt. So and what's this k? K, what does it mean? It is called as integral kernel. Another name is there. It is called as integral kernel. This t0 and t1, these are constant, depends upon the problem, we have to fix it. Okay, so this is called as integral transform. Okay, so now we are going to discuss about what this means Laplace transform. But before we are going to see Laplace transform, and one more thing, we are going to discuss about Fourier transform also. That is also under the case of integral transform. So we are giving two different examples for integral transform. One is Fourier transform, and second one is Laplace. So what's our Fourier transform? Same like that, both Fourier and Laplace, both are integral transform only. But this k and also the limits will be there. It will be regarding the chain, that is defined by Fourier and Laplace, different things. What is mean Fourier in the sense, Fourier transform in the sense, if for this case, my integral, this is integral kernel is there. Integral kernel for this Fourier transform, my k of s comma t is nothing but e power minus ist. Okay. And also I put the limits t0 and t1. My t0 is starting from minus infinity to 2 and t1 is plus infinity. So how can I write this transform? Actually it is t of f of t. For Fourier according, I give another notation like that, just f of t. So it is also like transform, just a notation for understanding this Fourier. I introduce this symbol f like this. So how it will be? My limits will be from minus infinity to plus infinity. My k is nothing but e power minus ist, and given function is f of t dt. Okay. So this is called as Fourier transform. So next thing, now coming to our topic, what is Laplace? So Laplace in the sense, here my k of s comma t is nothing but e power minus st only. Here ist, e power minus ist, here e power minus st only. Okay, and my limits here are two cases. First one, I just consider my limit, my t naught is from 0 and t1 is infinity, positive plus infinity. So then what is my Laplace? So Laplace regarding, I write this L like that. L, it is called transform of some function f of t. Laplace transform of t is nothing but integral 0 to infinity e power minus st into f of t dt. And this is called one type, and another one more type is called, this is one type. My limits will be 0 to infinity, and second case I can write it is called two sides Laplace transform. Another one more kind. For that case, what is in the sense, my limit is not from 0 to infinity, my limit is t naught from minus infinity to, and t1 is plus infinity. So limit will be changed for this case. It is, whenever limit will be 0 to infinity, it is first case, it is one sided. Two sided in the sense my limit is from minus infinity to infinity. Okay, but my for Laplace transform, my integral kernel will be e power minus st. Here for Fourier transform, my integral kernel is e power minus ist. That's a main major thing. Okay, this is the only thing you are doing, that actually Laplace transform any given function, you just multiply the integral kernel and do the integration. The output will be fully function of f of s. Okay, so next thing, I give that some application point of view. What do you do? Well, why are we are doing integration something, integral kernel we are doing multiply something, that from that what do you get? Okay, so I give application point of view, application of Laplace transform. Okay, so we already first starting itself I told that have many peculiar types of equation is there, you can solve that with the help of Laplace transform. Okay, so for simple I take that linear ODE equation. Suppose that we have studied many equations already. Suppose this is my equation, y double dash minus y equal to 0. Some differential equation is there now, so we have to apply many methods we have studied. Okay, so many methods we have studied, we have to, after that, after applying all the methods, we study a solution and find what is my y of t. So many solution methods is there, we have already studied. Okay, so homogeneous, linear, Bernoulli, exact, many things are there. You have to, any differential, some differential equation is given, we have to find the solution. Okay, that is normally we can do. So with the help of Laplace, what you do? Okay, that is another kind. So what is the Laplace? It's doing that. So a given problem, so some function, something will be there. I apply Laplace transform on this differential equation. Okay, first Laplace transform. So after applying Laplace transform, this differential equation will be transformed into some algebraic equation. Okay, so studying differential equation and comparing with algebraic equation is easy. Okay, so after applying Laplace transform, this equation will be converted into some algebraic equation. For algebraic equation, you can find the solutions also easy. I just said this is some f of s. Okay, for this one I have to find some solutions of that. Okay, for that algebraic equation. Solution, now solutions in my hand. After that, what is I do in the sense, next Laplace transform here apply. Now I do that inverse Laplace transform. Inverse Laplace transform. After that inverse Laplace transform, I reach that original solution, my y of t. That is the beauty of Laplace. Okay, so some difficulty will be there here. This problem will come after applying Laplace transformation is going to be algebraic. After that, I solve the algebraic equation. I get a solution from that. From the solution, I again apply inverse Laplace transform. Then I reach the main solution of the given problem. That is logically we are going to do. You got it? So this is a main introduction to Laplace. Okay, this is the main phenomena background we have to do. Okay, so a simple thing, just go to small function something given, how to find Laplace. I just give one or two problems. From that, it is nice motivation for you. I think that just see that some examples. Suppose my given function f of t is simple 0 for all. Here my t is for all t is positive. Given problem itself, they tell t is positive, they mention. So for this given function, I want to find the Laplace transform. Okay, so how to find in the sense, that is my question actually. So we know that integral kernel, everything, no, it is integral kernel is e power minus st. So what is my Laplace transform of f of t is equal to integral, my limit is from 0 to infinity, because my t is positive only, t is from 0 to infinity, limit is, and my integral kernel is e power minus st into my f of t. Actually just I write one time, f of t dt. This is my Laplace main thing, okay, formula. So in this given problem, my f of t is 0, therefore integral 0 to infinity e power minus st, my f of t is 0 times dt. So it is nothing but integral 0 into anything 0. I want either limits 0 to infinity 0 times dt. So what is the integral of 0 with respect, in my limit will be 0 to infinity is 0. So this is my final f of s, Laplace transform output. Okay, this is my input f of t and my output f of s is 0. Okay, but here very important thing we need to note that in this step one crucial thing is hidden there. So how I write directly, it is 0. Okay, because think that suppose I want to do integral like this in the sense, so 0 will be outside. So simply students what they think and all, 0 will be outside, 0 to infinity dt, therefore 0 into t will be there, my limits will be 0 to infinity. So 0 times infinity minus 0 times 0. Okay, upper limit minus lower limit they do. So here 0 times infinity, they writing 0, it is fully wrong actually. It is indeterminate form, yes or no? So how I write this is directly 0. Okay, so apply linearity property very correctly here. Linearity property plays a major role. Linearity property. So how I integrate this actually? What is happening here? So integral 0 to infinity 0 into dt is there. Okay. So whenever you are saying linearity property, 0 will become outside, 0 times integral 0 to infinity dt. So in this step, whenever the limits will be infinity, we have to be very careful that, please note that, not any function with the limit will be infinity is involving f of t into dt. What is the definition of integral is my limit r tending to infinity, integral 0 to r f of t dt. This is the main thing. This is the definition of that. Okay, whenever limits involving infinity. So now you apply the same here. What you get? So limit r tending to infinity 0 times integral 0 to r into dt. Okay, so here what we do now, after that integral dt is t only. So limit r tending to infinity 0 times t 0 to r. Okay, so limit r tending to infinity, 0 times r minus 0, it is r only. Now 0 into r anything will be there. Now it is 0, limit r tending to infinity, it is 0. Now after that we are applying that there is no r involving that, therefore the answer is 0. So integral 0 to infinity 0 into dt is 0 based upon this. Okay, so very careful how to do that integration in the limit involving infinity, very careful that. Okay, so it's a nice problem to you. So next one more example I have to find. So now first problem I have to tell that my f of t is 0, then my f of s Laplace output is also Laplace transform is also 0. So I'll give the second example. Now my f of t is some alpha, some constant is given. Here alpha is any real constant. Okay, for this problem, how to find my Laplace transform? Okay, so simple thing, and also given that t is positive. One problem also they consider that my t is positive. So how to find my Laplace transform? Laplace transform of f of t is equal to integral, my t is from 0 to infinity, e power minus st into alpha into dt. So again apply the linearity property, alpha is coming out, so alpha is constant, integral 0 to infinity e power minus st into dt. Then integral of e power minus st is e power minus st divided by minus s is a constant. My limit is 0 to infinity. When you are applying the limits, you have to be very careful that we already know about what is that my e power minus infinity values 0 and e power 0 is 1. Okay, this is a well known for us. So now we have to apply the limits there. So apply the upper limit infinity. For t you are going to guess t is a variable. Okay, so applying upper limit infinity e power minus st is there. So infinity will be here. Here s is plays a major role. Here minus will be there. My s is positive, then only e power minus infinity I can reach. Suppose s will be negative, then it's double that, it's going to be e power infinity is and so on, going to increasing and it's going to be infinity. Okay, so very careful that here for limit existence purpose I assume that my s is positive, then only I can get a limit. I mean it's going to be e power minus infinity I can reach getting a numerical value, otherwise it's going to be infinity. Okay, so we need to assume that my e power minus st, here my s value is positive. So next thing, so my problem is alpha is outside, e power minus st divided by minus s, my limit is 0 to infinity. We assume that s is positive, then only we can get that here e power, apply the upper limit, it is e power minus infinity minus my lower divided by minus s is common, there is no t involving here. Okay, my lower limit 0 into s, it is 0, so it is e power 0. 0 having no signs actually, 0 having both signs positive and negative. Okay, so now we can get that alpha times e power minus infinity is 0 minus e power 0 is 1 divided by minus s. So minus minus now cancel, minus 1 by minus s, minus minus cancel, therefore it is alpha by s. So Laplace transform of my f of t, what is my f of t? F of t is Laplace transform of my alpha is alpha by, this is my output, f capital F of s. This is true only when if s is positive only. This is more important. This is called region of convergence. When s is positive only, we can reach that. Okay, so very careful that doing Laplace transformation, applying limits. Okay, it's a peculiar rule. Okay, so many formulas we can for 0, alpha, then t power, and many formulas are there. Okay, I feel this is okay for you. So next you have to go, I give access to you. Please try for Laplace transform of t or Laplace transform of t power n, what you get. Okay. Upcoming classes we will discuss about the solutions. Okay. Just try for it. Upcoming classes I will again solve this also. Okay. And we can do further more things on Laplace transform. Thank you all of you.
Like, share and subscribe. Hit the bell icon for more updates.